Next, we will discuss the properties of definite and indefinite integrals. Let's start with the properties of indefinite integrals. We can factor out a constant from an integral, or split an integral of the sum or difference into a sum or difference of the two integrals, just like the derivatives. To practice the taking out the coefficient property, let's find the indefinite integral of x by factoring out 1/2 and recognizing the antiderivative of 2x. We can do the same for x raised to any power n. Let's factor out n plus 1 and recognize the antiderivative. To practice this property, let's find the indefinite integral of x plus 1 by splitting the integral into the sum of 2 and then integrating each one separately. Similarly, we can find the indefinite integral of 5 minus x by splitting the integral into the difference of 2 and then integrating each one separately. We can do the same with definite integrals as well. That is, we can factor out a constant from an integral and or split an integral of the sum or difference into a sum or difference of the two integrals. To practice the taking out the coefficient property, let's find the definite integral of 2 from -1 to 1 by factoring out 2 and recognizing the antiderivative of 1, and then using the fundamental theorem of calculus. We can do the same for any number k. Factor out k and integrate what's left by using the fundamental theorem of calculus. To practice this property with definite integrals, let's find the definite integral of x plus 1 from 1 to 2 by splitting the integral into the sum of 2 and then integrating each one separately by using the fundamental theorem of calculus. Similarly, we can find the definite integral of 5 minus x from 2 to 5 by splitting the integral into the difference of 2 and then integrating each one separately by using the fundamental theorem of calculus. Definite integrals have additional properties inherited from them being the Riemann sums in nature. To practice the first property, we can now differentiate the cumulative sum function with the variable lower limit of integration by applying the property first and then using the first part of the fundamental theorem of calculus. To practice the second property, let's find the definite integral of the following function again. Recall that previously we have found the same integral by simply computing the area under the graph. According to the property, we can split the integral into 3 integrals according to its piecewise definition. And then we can compute each one separately. In summary, we have already observed how some properties of derivatives translated into some properties of integrals. In the future, we will also learn how to convert the product rule into an integration technique called integration by parts, and how to turn the chain rule into a technique called substitution. We introduced and discussed the properties of indefinite and definite integrals.